Welcome back to the finale explainer in our Spring RestClient playlist. I've been walking you through the setup, and today we are finally crossing that finish line. We've spent the previous parts of this series meticulously configuring our client, and now it's time to wire it up, run it, and actually prove our code works exactly the way a modern production-grade application should. Here is our roadmap for the finale. First, running the Spring application. Second, testing endpoints with curl. Third, verifying the JSON responses. Fourth, the RestClient API recap. And finally, next steps and source code. Let's jump right in. Section 1. Running the Spring application.
To validate that our REST client is truly production-ready, we're going to follow a highly methodical three-step approach. Step 1 is starting the app. Step 2 is hitting the endpoints. And Step 3 is verifying those JSON responses.
Step 1 is incredibly simple. You just open up your command line right at the root of our project directory and start the application using the Maven wrapper. You literally just type /mvnw space springboot:/run. Hit enter and let Spring Boot do its magic, spinning up that embedded server so we can finally start making some requests.
Section 2. Testing endpoints with curl.
Section 3. Verifying the JSON responses.
All right, let's look at our first test. We're firing off a curl command to localhost 8080/API/posts with the user ID query parameter set to 1. And, exactly as we expected, we get a JSON array back containing those specific post objects where the user ID is exactly 1. Notice the clean structure we got back here, an array of JSON objects with ID, user ID, title, and body. Perfect.
Next up, we're hitting the search endpoint, but this time we're throwing multiple query parameters at it. We're calling API/posts/search, passing user ID equals 1 and title like equals queer. The crucial thing we're testing here is making sure our client dynamically strings both of those parameters together correctly. And sure enough, when this executes, our query param calls successfully return the filtered JSON array.
Okay, let's see how this behaves when we swap out query parameters for path variables. We're using curl to hit our API/posts/1 endpoint. By passing the number 1 right into that URL path, we're asking for a very specific post. And instead of an array, the API beautifully returns just a single, perfectly mapped JSON post object with ID 1, a title starting with sunt.facere, and its corresponding body. It's routing exactly the way we designed it.
Now for the big one, our post request. This brilliantly illustrates how our per request headers and request bodies actually function out in the wild. We use curl-x post to our API/posts endpoint. We pass the -h flag to set our content type to application/JSON and the -d flag followed by our raw JSON payload containing a user ID of 1, the title hello, and our body string. And check out that response. The demo API gracefully fakes the insert so we don't break production data, and it echoes back our exact body with a freshly assigned ID of 101.
Section 4. The RestClient API recap. Since this is the finale, a full recap is an absolute must. Let's review exactly how we built this. Notice how we initialized the builder using RestClient.builder and called .build at the very end. We set that foundational URL using .base URL, and crucially, we wired up both the connect and read timeouts. Remember, for the connect timeout, we used http.newbuilder.connect timeout. For the read timeout, we actually had to use the JDK client HTTP factory, calling setReadTimeout. That two-step timeout setup using the JDK client is super vital for a resilient application.
Moving right along, we also mastered some seriously disciplined header handling. For headers that we needed on every single call, we used .defaultHeader with a name and value. But for headers needed on just one specific call, we used .header or the .headers consumer method. We also successfully parsed variables into our URIs. For a path variable, it was as clean as .uri passing the path string with the ID variable inside curly braces, followed by the ID object itself. And for query parameters, we utilized that awesome builder block, .uri passing a lambda that builds the query param.
And to bring it all home, we tackled one of the absolute trickiest parts of Java REST clients, generic collections. We utilized .body passing a new parameterized type reference. This allowed us to safely map generic response types, like our list of post objects, without falling victim to type erasure at runtime. It's an absolute lifesaver.
Section 5. Next steps and source code.
Let's summarize our total victory today. What did we actually accomplish? Well, our timeouts are working correctly, saving us from those dreaded hanging threads. Our default headers are active. Our query params are parsing accurately. Our path variables are routing exactly as expected. And our per request headers are firing right on demand. Our externalized configurations and robust request routing are fully active and thoroughly tested.
I know we covered a ton of code across this whole series, but don't worry, the complete runnable source code for this entire project lives right here on GitHub at github.com/programinfuse/spring-restclient. I highly encourage you to go clone it, run that Spring Boot command we used earlier, and actually follow along with those curl commands yourself to see it all in action.
Also, please make absolutely sure to check out the detailed article link in the description below for the full written guide to everything we've discussed today. As we wrap up this explainer and close out this entire Spring RestClient playlist, I have to leave you with one final question to chew on. Now that your modern, fluent REST client is fully production ready, which legacy REST template in your codebase are you going to replace first?